Okay, so what we have here is this is just a quick introduction to the engines that you have on your boats now. You do have the Yamahas, but I believe Colin was saying he's pretty well going up to the Toyotsus. So we're going to be concentrating mainly on the Toyotsus. So we're not going to solve all your problems in this little session, but we're going to try and kind of get to the root of some of them. Now, a couple things when we look underneath the cowl here. We see some bits and pieces. First thing we need to do is that when I'm starting this engine, where do I put the shift?
Neutral.
In neutral. So I'm in neutral somewhere. Okay, so I'm in neutral. And then when I pull the cord, the engine moves, right? Now, if I put this into forward, should I be able to pull the cord out?
No.
This is missing the dog. There should be a little piece that drops down in here so that when I do that, as on this guy here, you'll notice when I pull here, here. So I'm out there, I'm having a problem starting the engine, so I give it full throttle and I lean over and I actually shift it into forward or into reverse, and then I go like this and the thing catches, it's gone, I'm in the water. So that needs to be replaced. The engine should not be able to start in gear. Fine now. So looking underneath the cowl here, and these are some of the checks that you need to make when you're starting up. First thing what we're doing is we're just checking for any oil leaks, any water leaks. So if I see like a white powder, what does that tell me?
It's salt.
Yeah, so I've got a salt water leak. Could be a head gasket leaking, something like that. And again, you're not in a position to do anything about it, but you should note it and you should bring it to the attention of whoever's doing the maintenance, because these leaks don't get better if I just ignore them. So you need to do that. You need to check for any oil, because again, remember, this is a 4-stroke engine, so it actually has a crankcase, has a sump. And we need to check the oil for that. So we need to kind of do a physical check. We need to ensure that the cables all operate smoothly, and actually this is a very nice throttle operation because it's what I call push me, pull me, because when you operate the throttle, it does it by a cable in both directions. A lot of older engines would have a spring to return the throttle to neutral or to idle. On this one it has cables, so it works very well. The only thing is these cables need to have grease on, so these are getting a bit dry, so it might be an idea just to have a little bit of, you know, winch grease. You guys service your winches?
We did last year.
Yeah.
So a kind of it's a kind of green.
Yeah, and
green
that will work just as well on these cables. So you just put a bit on your finger and then just operate it back and forth, and that'll get enough inside, because not only does it make it smoother, but the grease also stops any moisture from getting inside here. So just a little bit in there, and that's that. Then the other thing, because it is a 4-stroke, what we do every day before you start your car, you check the oil. Everybody checks their oil.
Every day.
Now that's fine for your car, but here, you know, you're in a club situation and that you have no idea when the oil was checked last. So always assume that it's never been checked. So we need to check it. First thing we need is a clean rag, not some dirty thing that we've seen laying around. One thing about these engines is they burn very, very clean. Like if anybody's been on a small sailboat with a diesel engine, the oil's pretty black. On these, it's pretty clean. So we pull it out. Always good plan, wipe it off. It has a screw thread. Now what you need to do, there's a maintenance manual for the engine. If you look in that maintenance manual on this engine, it says to screw it in to check it. You'll find a lot of transmissions in that have that same setup. You don't, you put it on the top of the threads and check the oil. So that's important to look in the book. You know, you all can't remember everything. So the thing is, we take it, we put it in, and then we pull it up.
That's why it was always too low, because we didn't screw in, so it was always
Right, and so there you can see this engine's actually overfilled. Should be between the marks. Try not to have it above the top mark or below the bottom mark. Halfway is probably the place to be. So the thing is, it has an O-ring for a seal. So when we tighten this up, all you need to do is the O-ring touches, give it 1/8 of a turn. That's it. Don't show everybody how strong I am and crank it up, because two things: it makes it really, really hard for the next person to get it undone. The other thing is, if we over tighten it, you'll destroy the O-ring. You'll push the O-ring out and then it leaks. So it touches, and then about 1/8 of a turn is fine. You should always have like a Leatherman or a pair of pliers, because you might do it properly, but the guy before you didn't. So then you can undo it, kind of a thing. Now, as far as the lubrication system is, you check the oil there. We all know about the little oil light on the front of the engine?
No.
No.
Okay, so so it's one of those things, you don't really need to know about it unless it comes on. If it comes on, it's telling me that I'll have low oil pressure and then I need to shut the engine off, just right there. No, I don't believe the Yamaha has one. This has one.
But you can't see the light really.
You gotta stand on your head to see it. It's right there. Yeah. There's no oil filter or anything like that. This engine's overfilled. You can drain the oil. There's the plug right here.
Do you see it, Simon? Yes.
So that's the plug.
Do you see it?
Yeah.
That's the plug. It's always a good idea, if you're going to pull that plug out, is to have the little gasket that's inside there, because you may just lose it, or it might be overused and doesn't seal.
I just have a question. You are seeing we are saying about oil leakage. So for the water we can see the white trace, but for oil, what
They're just oily.
Okay, so at the bottom or
Be in the case here. You
Okay.
might see it if it's really leaking. You might have these little drain holes here. If you
Okay.
see oil dripping out of there, you know you got a problem.
okay. So good, thanks.
Okay. Now, starting these in. So we just start for a second. There's a fuel filter here in the system. So what happens is the fuel comes in here, goes through the line. This is the fuel pump here. This is the fuel filter. Now again, your fuel should be clean, shouldn't be a problem at all, but that should be probably changed annually. So whenever the engine's being given a tune-up, that should be changed. Starting the engine. A couple of things. Before we start the engine, we have to make sure that the cord is in good shape. So slowly pull it out and ensure that there's no frays or anything in the cord. Now starting, you need to understand how the ignition works on these. In your automobile, you have a battery. So battery, we have a battery, we have a coil, and all kinds of good stuff like that. So we need anywhere from 10 to 20,000 volts to fire that spark plug efficiently. Very, very low amperage, but very, very high voltage. It has to be able to jump the gap. We need to develop that. We don't have a battery to assist us. We don't have an alternator or anything like that. What we have in here is we have a magneto. Anybody familiar with a magneto?
Spins.
Spin. So all it is we spin a magnet through electric coil. And when that magnet goes through the coil, it breaks the field. And it's when that magnet flips by that the actual energy is produced. If we just go slowly, it doesn't produce very much voltage. So we don't get enough voltage really to get a good hot spark. So what we need to do is we need to spin that magnet as fast as possible through that field to get that volt. When the engine's running, not a problem, but started. So when I'm pulling the engine, I need to have short, quick strokes. Better, because again, you know, depending upon the person's physical ability, the area in the boat, you know, you don't want to be taking anybody's teeth out or anything like that. So you're better, instead of trying to get it all the way out, give it a good, quick, short pull. That'll get enough spark to fire the spark plug. And then away we go.
Just a quick notice here. I've seen someone like pulling and then hitting the boom on the elbow and then like losing a bit of skin here. So again, you're right. Be careful with the people behind. It just has to be
Oh, yeah.
quick and.
Because sometimes, depending upon the boat, you'll find that especially for, like people that are small, like that they don't have the upper body strength. Sometimes if they squat over top of the engine and pull with both hands, first thing what it does, it gives you more power, but it also, you
Make
can't
it
pull it
safe.
that far. So then it just like that you can get. So that's another way to do it. Obviously, depending upon how the boat is set up, you may not be able to do that. But in an ideal, just pull, then you have both hands to do it. So one of the problems you have is that the engine doesn't start. So normal starting, pull the choke, set this just a little bit past the old tortoise there. It even says start on the handle. And then we give that short pull. The God's willing, the engine starts. What do we do with the choke?
We wait a bit or.
Yeah, it depends upon the engine. We want to get the choke off as soon as possible. On a cold day like today, we might have to ease the choke in. Some engines, you got to push it in right away or else they stop. They'll flood. So that's the thing, the choke, whatever. Now what you find is,
So what exactly does the choke?
Yeah.
okay, what the choke does is
Good one.
it closes a plate inside the engine, which then gives us higher vacuum in the engine, which then means I pull in more fuel versus air. So that's what it's an enriching device. It gives us more fuel, and so we can start the engine. But the problem with that is if the engine doesn't start, now we have too much fuel in the engine, and it won't start. The spark plug will get wet, and all kinds of stuff like that. So if we're in that situation, that's called flooding. How many you aware of the term flooding? It's the thing that if you drive cars now, you don't worry about things like that because they don't have chokes and they don't have anything. You just turn the key and away it goes, or push the button. But on these, they will flood, especially when they're cold. So what do we do if it floods?
But it's it.
We could let it sit, but we want to go sailing. Or we're at the mouth of the creek, we want to get in. So the thing is, we have
What do you want?
too much fuel in the engine.
Yeah.
Okay, so then what we got, first thing is, what gives us more fuel in the engine for starting?
The choke.
So the choke. So what do we do with the choke?
Push that.
Push the choke in. We want more air in the engine, which controls the airflow into the engine.
Throttle.
The throttle. So choke in, full throttle, pull. And if it's flooded, it should start. Again, should, but in most cases it will. And then once it starts, we have to back off on the throttle. Because otherwise, if we just leave the choke, we're just going to flood it even more. We don't want that. Okay, so a carburetor is a Venturi. We all know about Bernoulli and all that kind of stuff.
I think when you have flow,
Yeah. Anytime we have a restriction,
Oh, okay. Yeah.
pressure drops in it. That's all. And that's what the carburetor is sitting with ambient pressure on it. The Venturi's in the carburetor. The faster the air flows through, the greater the pressure drop, the more fuel that will come in. So, but we open the throttle, we get more air in. And so that's the whole idea, is that if we leave it at idle, we have high vacuum because we're causing a restriction, and that gives us more fuel as well. So if it doesn't start, choke in, and then if it still doesn't start, then you got to kind of fiddle with the choke and the throttle and all that kind of stuff. But that's the way to go. The other thing is that, I see it like I worked for Cooper long enough, you see people that go down to the boat, they start the engine because they want to make sure the engine runs. Okay, you got the engine. Then they go and they get the sails up and down and in and out and all that stuff. Meanwhile, this poor little thing is sitting there going tickety, 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 tickety. Don't idle them for excessive period of time. In the book, it says run them for about 2 or 3 minutes at idle and then go. So that's all you want to do. And even then, if you're running them at idle, always bring the idle up a little bit higher than just no throttle, bring it up, get the speed up a bit. Because what happens is, because they're cooled by the ocean, and especially here, as we all know, the water's quite cold, they won't warm up. And then you start getting carboning up, you get gumming up because the fuel's not burning properly. So never let them idle for more than 2 or 3 minutes. Either shut them down, or better yet, go. So you want to do that. So these are raw water cooled engines, no antifreeze to check or anything like that. So where does the water, how does it get in the engine?
Intake.
Okay, so the intake is down at the bottom here somewhere. It's right there. So that's when you're checking it. When we pulled this out, we found all kinds of mussels and stuff growing on there. And so we chipped them off, and if somebody wants it for their lunch, go for it.
So where exactly? Oh, here.
Right there.
Okay.
So there's the intake. How does the water get out of the engine?
It's at the top there. Yes, sir.
Okay. Does it get out of there? What's the purpose of this little hole?
Indicator.
It's an indicator. It's a little tiny telltale hole. Most of the water goes through the engine, down the leg here, out through the propeller. Okay. Only a very small bit of it comes out through that hole. That's just so that, like, if you're on a bigger boat, you look over the stern, you can see the water coming out of the exhaust. You know, unless you're in the water, you wouldn't see anything. So that's what that's for. So the thing is that if there's no water coming out of there, it could be that the water pump has failed, but in some cases, it's just that that hole is plugged up. So if you get no water coming out of there, get your little toothpick or whatever, and just make sure that hole is clear, start the engine, and if water's still not coming out, well then you know you have a problem somewhere in the leg here. So the way it works is, this is called the power head. That's the engine itself. That's the engine itself. It drives a shaft, comes down through here, and the water pump lives right down in the base here. So the water pump always is in the water. And so that's why if you were ever to run the engine with the leg out of the water, it's not good for it. Not only will it overheat, but the water pump is a rubber impeller, and you'll burn the impeller out. So this always needs to be in the water. The ideal depth for it is this plate right here. The further down, the less efficient the engine is, because we have to pump the exhaust against the water pressure. So the farther down the leg is in the water, the less efficient the engine itself is. So we want to have it somewhere down to about this plate right here. The way the exhaust, so what happens is the engine pumps out its exhaust. That exhaust is mixed with the cooling water, and it all flows down inside the leg here, comes out the end of the propeller. And when the propeller is in forward gear, the rotation of the propeller and the water going by it helps to evacuate the exhaust from the engine, which is really good in forward. But as soon as we go into reverse, now the propeller is going in the opposite direction, and so the propeller is starting to pump not only water, but exhaust gas, and we get cavitation. And I'm sure you've noticed that. You're coming in, you want to put it into reverse to stop it, you pop it into reverse, and the engine does strange noises, gurgling sounds, and what it is you're getting gas on the propeller, and that propeller is very, very inefficient. And that's one of the problems with these exhausts through the propeller. The older style engines used to have shear pins. These do not. All they have is they have a rubber sleeve that connects between the shaft and the propeller. So if you hit anything, that sleeve may go and then you've got no drive at all.
That saves the engine, pinion gear.
Yeah, that's the idea. Now the way we work is we have a shift mechanism, which is on the front of the engine. Our actual gears are sitting right down in this area here. And so all it is forward, neutral, reverse. And it's a sliding gear. There's a pinion and two crown gears, and it just slides back and forth into the two. So it's really important. There's no synchronizers or clutches or anything like that. So when you're shifting, the shift has to be crisp. Don't ease it in. If you ease it in, it'll grind, grind, grind till it pops in. So just crisp shift. Now the other thing is that when we're talking about shifting, is that when I want to lift this engine up, I pull that back and it comes up. If I'm in forward gear and I hit something, I want the engine to pop up. That's what it's supposed to do. But that's kind of a bummer when I'm in reverse, because as soon as I put it in reverse, the engine wants to come up. So what it is you see this little plate here. I'll come up here and have a look. You see this plate? Okay. That's the reverse lockout. When I'm in forward gear, this pin is up. Now if I shift into reverse, that pin drops down, and now I can't lift the engine up. So what'll happen is, if you want to lift the engine up when it's stopped, obviously, I go into forward, it lifts that plate up, and I can lift the engine up. So if you can't get the engine up, it could be that you need to shift into forward to get it up. You will not be able to get it up. Some engines will lift in neutral, but some have to be in forward gear. So always get in the habit when I'm lifting the engine, put it in forward, and then I eliminate that. And then what happens is people will bend that, and then it doesn't work. And then when they go into reverse, the engine pops up. So that's one of the checks that you need to.
How do you about that? So doing that.
It also becomes an airplane.
Yeah.
You know, once
Everything
the-
you just said has
That's
happened.
exactly.
Yeah.
And I know that's when I want to lift up. Actually, I bent over and put my finger just to release this one. But what you're saying, it's
Put
just
it in forward gear.
yeah. I didn't know that was this.
Then
main
it'll-
model
That's a
here.
lot
It'll-
closer.
Yeah, exactly.
It's easier. Couple of things that need to be, you'll notice here, there's a grease nipple here, a grease nipple there. Those are things that need to be greased because that greases the bearing. Now you have a lock here, a damper that you screw in, and it's supposed to stop the engine from, doesn't lock the engine, it's a friction device, so it's kind of dampens, and what happens is people over tighten, and then it doesn't work afterwards.
Last thing I think we were looking at before was the zinc.
Right, so the
Right,
zinc
and-
sits right on the bottom there.
Yeah. And just kind of what we're looking for, what it does and why it's important.
Okay, so what it is that, remember, this is operating in salt water, and so if we have salt water and two dissimilar metals,
Electrolytes.
aluminum, whatever else, makes a nice battery. Very expensive battery, so we don't want to produce electricity that way. So what we do is we put a zinc on, and if you're familiar with, there's a galvanic scale, which tells you the higher the item is on the galvanic scale, the less it affected by corrosion in salt water. So things like, we make things out of brass and out of bronze because they're at the top. Zinc is right at the bottom. It gives its electrons off really easily, so we use this as a sacrificial. So it's important. The other thing is, if you're changing this, make sure whatever surface is attached to is clean, because we have to have that good electrical contact.
So between
You keep it
between the
good-
two areas
good
here.
brush.
Brush, yeah.
Yeah, that's what we're looking for.
Wire
is it-
brush.
Yeah.
Yeah.
As long
Is
as
it
we-
like between here and here? You're saying it
Yes.
needs to be a good connection.
Yeah, it has to be a good connection. Yeah. The other-